Hello everyone, I'm Srimanti and I'm currently working as an ML engineer. So there are three main libraries that we often use when we are trying to implement any machine learning algorithms. So these are Numpy, Pandas, and Matplotlib. I have used Numpy and Pandas and Matplotlib previously when I was implementing machine learning from scratch using just Python, and also when I was implementing machine learning using standard libraries like scikit-learn. But today I'll be diving deep into the fundamentals of these three libraries and the functions that we use. And these functions, if you understand them thoroughly, if you go through the video very thoroughly and understand everything, then you will be able to understand any kind of machine learning algorithm online yourself, the code, and you will be able to implement these machine learning algorithms all by yourself as well. This covers the functions till the intermediate levels of ML. For the advanced ones, I'll make a separate video later on with the advanced functions of each of these three machine learning Python libraries, Numpy, Pandas, and Matplotlib. So first, I'll start with Numpy. Okay, so first we'll import Numpy. Next comes, let's talk about a one-dimensional Numpy array. We will talk about Numpy arrays till 3 dimensions. This is the first dimension, 1D, 2D, and 3D. We'll talk about the axis, which is a very important concept when learning Numpy. And we'll also talk about why we use Numpy arrays in the first place instead of Python libraries. So try to answer this question yourself and check the answer in shorts. I'll just give a hint. So Numpy arrays actually save space. They are very, very memory efficient compared to the Python arrays. That is why we often use, in most of the machine learning algorithms, you will see that we use Numpy arrays. Okay, so now, so this is a Numpy array. We have one-dimensional one, the most simple one. So now comes the axis. So what is the axis? So the axis tells us, the axis argument of Numpy actually tells us which axis to perform the operation along. So here in this case, axis actually, like suppose we have x-axis, y-axis, and z-axis. Similarly, here also we have similar things, but these axes can be anything. In like billions, millions, anything. We can have any number of axes. So here, the only axis available is 0 because it's like one-dimensional array. So the sum, obviously, you can guess it. It will be 10. np.sum, one-dimensional array. So this will obviously be 10. 1 plus 2 plus 3 plus 4. Next comes two-dimensional array. So I don't know, let's just have this kind of an array. 5, 6. So, yeah. So here, actually, we have 2 dimensions, right? So we will have 2 axes. So here, axis 0 means operating along the rows. So what do we mean by that? Let's just give an example. So let's just have sum. So the first axis, which is the axis equals 0, operates along the rows. Remember that. So let's do that. 2D. Axis equals 0. So if you can see, so what is happening? So we have like the rows have dissolved into one row, all the rows. So this explains why it's operating along the rows, right? So the rows have dissolved into one row and the sum are along the columns. Great. Now you can guess what would happen if I do axis equal 1. The other axis is obviously 1, first axis. So we have 6 and 15. Yeah. 1 plus 2 plus 3, 6, and 4 plus 5 plus 6, 15. Cool. And now if suppose we had this is obvious. So np.sum ARR 2D. So that would be the entire sum. 1 plus 2 plus 3 plus 4 plus 5 plus 6. Great. Now the next thing that comes is, let's just have a 3D array. So this will make things a bit more interesting. And we often have 3D arrays where, if you remember, we have 3D arrays when we are trying to deal with image data. We have RGB, red, green, yellow, different channels of colors. So that is why we need this. And we mostly need till 3D arrays. So that should be good enough. Let's have a simple one. 1, 2, 3. 4, 5, 6. Then 7, 7, 8, 9. And then I don't know, 10, 11, 12. This one, yeah. So let's print that out. Yeah, this is our 3D array. So after this, what can we do? Let's just calculate the sum. So now this gets a bit tricky. So axis 0 here means the outermost axis. What is the outermost axis? Let's see. Let's do that and check it out. You can make a guess here and see if you understand what I'm saying. So the outermost axis actually along the depth. So what depth do we have here? We have a 2 depth equal to, right? So this is 1 plus 7, 2 plus 8, 3 plus 9, 4 plus 10, 5 plus 11, 6 plus 12. And axis equal to 1 would be along the rows and axis equal to 2 would be along the columns. I hope this is getting clear. Now, always remember this, outermost to the innermost. So axis equal 1 would be, as you can see, so the rows have dissolved. So we had 4 rows earlier and we now have 2 rows. So 4 plus 1, 5, 2 plus 7, 2 plus 5, 7, 3 plus 6, 9. That's it. And I hope you understand this one now. 3D. This would be along the columns. So 1 plus 2 plus 3, 4 plus 5 plus 6 here is 15. Then 7 plus 8 plus 9 is 24. 10 plus 11 plus 12 is 33. I hope you're getting this. This is very, very important to understand. If you don't understand this, you will forever be like, what is happening in this with the Numpy arrays and what exactly is going on? Okay. So next thing comes is the shape. So shape is basically starts from outermost to the innermost. So the outermost, there's depth is 2, as you know here, as I showed here. The axis 1 is the rows, 2 rows, and then comes the columns. So 3, 2 cross 2 cross 3. Great. Now, can you mutate this array? Definitely. So let's just call A to be, let's just make A a new array and let's just not go into this. So 1, 2, 3, 4, 5, 6. That is better. Now, can you mutate the array? Definitely. Let's make this 2 and let's print out A. There you go. You can mutate the array easily. How can you index the array? Let's just say A02 would be 3. You can understand 0 is the 0th row. So the first row and the last column, 3. Now, similarly in Python, you can also do this. So this will be the last row and the last column as well. So that's, guess it, 6. Yeah, correct. Okay, now there's one more thing that's very, very important. np.linspace. So what does that mean? So basically, this is the start one, this is the end one, and 10. So in steps of 10, so we'll have 10 values between 0 and 1 equally spaced. So if you can understand this, yeah. The last value should be 1. The first value should be 0, what you specify here, and there should be 10 numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. As you can see. This is very important when you don't have data or when you're trying to plot the array using Numpy. So then this becomes very useful. So we have A as this. Let's just, okay. So let's just do something different now. We often have to concatenate 2 different Numpy arrays, right? So what will happen in that case? Let's just say this is A. Let's just say this is B, and we want to concatenate them. 4, 5, 6. Right? We want to concatenate these 2 arrays. So what would that look like? Let's just say we have C. Concatenation is also very, very useful when you're trying to do something different. Like when you're trying to use two arrays and you have like features separated across two different data structures, 2 different Numpy arrays, and you want to combine them together for training the algorithm. So then it becomes very useful. Guess what it would look like? Yeah, concatenation means just getting everything together. Yeah, this is what is concatenation. And there's one more thing that is often used, like arrange. So arrange would be like, suppose you want to get 24 numbers from 0 to 23. So this just generates them. This also is very useful when you are trying to use them in the plotting different points. So suppose you don't have the x-axis points, you have the y values, and you know they're equally distributed. So you can just use this to generate a sequence of numbers. That's very, very useful. Next thing is the reshape one. Reshape is also very useful. So reshape one is often used when you're trying to do the convolutional neural network. I'll come to that very soon. So there, when you're trying to do the final layer, there you have a fully connected layer. So that one is actually flat. You have to reshape everything back into a completely flat layer. It won't have any dimension, just one dimension. It won't have multiple dimensions, just one dimension. So now this multiplication 2 into 3 into 4 must be 24. So, and then this gets distributed in this order. So I hope this was very clear. If you have any questions, please drop them in the comments. I'll try to answer them. If you want me to cover any other functions as well, please let me know, and I'll try to explain that. I think this should be enough for any kind of machine learning algorithms you are trying. For Numpy, basically, I covered it in detail, and this should get you going good. If you have any doubt, please rewind it and try to understand it. I've explained it in great detail. I hope this helps. Thank you. Okay, so now we are done with Numpy. Now I'll move on to Pandas. So Pandas is a very important Python library that we often use when we are trying to analyze any kind of data set, or we're trying to understand the statistics behind the data set, or we're trying to remove the missing columns, manipulate the data set a little bit, see how the data looks like, see the mean, median, mode, and different statistics of the data, find the correlations of data. So I'll go into each of these in great detail. So let's start. So first comes importing Pandas. So once this is done, let's, okay. First, we'll get the dataset. So I have my dataset in this folder. You can place it anywhere. So I'll link this dataset in the description of my video. And you can also use this dataset when you're following along. So in case you're wondering, so this is the dataset, Kaggle dataset. I always use Kaggle dataset. It's always the best source, cheapest and the best source for solving any kind of ML problems, for just trying out anything in the, and anything you want to do. So we'll use this dataset. So first I'll print out the data frame. So DF is a data frame. First I'll print out the columns. Next we'll see the first 5 rows of this dataset. Next we have the last 5 rows of this data frame by doing df.till. So now what comes very important is the sample. It's not very important. Like this helps us to get 6n number of different rows from our dataset. So at random, this just selects 6 rows randomly. Next, what comes is very, very important. So which is the shape. It's the same as that in Numpy. The rows cross columns, and it shows us the different dimensions of our data. Next, what comes is the describe function of the data frame. So this one basically is very important to understand the statistics behind the data set. So it gives us the count, the mean, the standard deviation, the minimum, 25 percentile, 50 percentile, 75 percentile, and the max. This helps you understand the data set more thoroughly. Now comes doing info to get some additional information. And also this is important in the sense that here you can see the non-null rows among the total number of rows. So the total rows is 54035, and you can see all the features, they have non-null data points. So this is very important. If you have any missing data, then that will corrupt your training. So you need to always check in the missing data and remove them or deal with them somehow. So this is the correlation function, which is like a different thing altogether. This will help you to remove the features that you don't think are important. How? So basically, this one shows the correlation between all the integer columns in your dataset. Yeah. So as you can see, this is the formula for correlation. So here, like the cap diameter has 1.0 correlation with itself, obviously, because they're the same thing, so they are highly correlated. And if you see like different kinds of features, if they have very high correlation, then you can remove them because they will be degenerate features. Okay, now comes I log 0. df.I log 0. This helps us to get any the ith column, ith row from the dataset. And the column is simple. If you want the cap diameter column, you can just use this. This will show the column. And you can also get multiple columns from the dataset, as in like this. So you want, suppose, 2 columns, cap diameter, and let's say you want cap shape. This will give you 2 columns from the dataset. Next comes is null. So this is very important, as I said, to check the null values. You can also use info. You can also use this function. If anything is null, then you need to remove them. Or you can fill them up with different things. Removing is a choice. So like here, drop NA will be removing all the non-applicable columns. Not applicable. It's not applicable here because we don't have any. But in other cases, it would be applicable. Now comes like if you want to change a particular column, a particular feature to basically to have a different data type. So we would have as type float. So this would give you a different data type for the same. Now comes filtering. Filtering is very, very important. Suppose you have a score variable and you do not want, the score is 0 to 100. You know that. It's in the problem statement. But in the data set, you find that there are some which have score greater than 100. Just a human error. So you will need to filter that because you don't want, you know that this is noise and you can remove them beforehand. So you can do that by filtering. This is an example. Also, if you want to generate more data, more features, so from the already existing features, you can do that too. So this is the way to generate a new feature. Cap diameter. Let's just say we want to multiply by 3. Triple cap diameter. Yeah. X would be X into 3. Can be anything you want to do. We are just doing a very simple thing. Now, if you have DF, you can see that here's the new column, triple cap diameter. Now comes a very important thing, last but not the least. So basically, in the dataset that you're getting, you would always have the target variable as well, right? It would not be separate. Sometimes it would be, yeah, but in most cases, it's not separate. For example, here, if you see, we have the class in here. And we don't want the class. We want the class to be separated out. So we will drop the class column from our data. So we would have now X as this. And for Y as well, we will also drop it from our data. For Y, we will need the class because it's the target variable. So as you can see, we have got the target. We have separated the target from the features. Yeah, so that was all about Pandas. This should cover everything you need to know till the intermediate level of machine learning. And that should be enough for now. If you have any questions, if you want me to cover any other functions, then please drop in the comments. I'll do that. And if you have any question, like in general, any question, if you did not understand anything, I would recommend rewinding the video and trying to understand it, trying to implement it yourself. The dataset that I used is from Kaggle. I'll link it in the description, and I'll also share this notebook in case you have any doubts. But it's very important to understand these things thoroughly because these are the very basics of machine learning. Okay, so now as Numpy and Pandas are both done, now we'll move on to Matplotlib. So Matplotlib is a Python library that is mostly used for drawing plots and bar graphs, and it is an extremely important tool for analyzing any kind of data. So I'll talk about mostly the functions of Matplotlib that we generally use for dealing with any kind of data, whether it's a regression data that is continuous data or it's a classification data or discontinuous data. So I'll show you how to plot them, how to have scatter plots, bar plots, and normal plots that we generally do. 3D plots, 2D plots, that should be good enough. Yeah, so that should get you started with understanding any kind of ML code online, written in Matplotlib. And after this, you can just go on to Kaggle I'll suggest go on to Kaggle, find any data set and try to analyze it. Try to draw plots, try to manipulate it, change some values and see how it's affecting the overall data. So try to do that. That will solidify your basics and your understanding of Matplotlib. So let's start. So first I'll import Matplotlib. So this is the standard way to do that. Import matplotlib.pyplot as plt. Next comes just the absolute basic of Matplotlib. You have some x list, you have a y list, and you want to see how y relates to x, how y is dependent on x. So let's get that going. So first is that I just now taught you linspace, Numpy linspace function, which basically plots. This is the first one. This is the first value, and the last value, let's just have pi and 200 points. 200 equally spaced points between 0 and the max value, which is 2 multiplied by pi, 2 pi. And y is np.sin x. Now you will have to do plot. This is the most basic function of everything. You just see this is the sine curve from 0 to 2 pi. And this is very basic, absolute basic. Now comes a little bit more advanced. Not advanced, but a little bit closer towards the intermediate. So what we'll do here, we'll add the figure and axis. So what are they? So Matplotlib graphs our data on figures. So for example, Jupiter widget is a figure and so on. So each figure can have multiple axes. So these axes, on this axis, you can draw multiple plots so that you can compare the different graphs. I'll show you an example. Let's have similar one and let's compare sine and cos. So how can we do that? Let's have the same thing, 0 to np.pi and then 200 x. Now let y be sine x and let z be np.cos x. Yeah, so maybe just not get into z right now. So now be very careful. So figure and axis. We can do that by using plt.subplots. Remember this is very, very important. Axis.plot would be x and y. And then you will have plt.show. You can guess this will show the same thing. But you have here axis and the figure. So now what you can do is let's add something. So axis.plot x comma z. So as I was writing z there, z is np.cos x. Cos x. So now if you remember, if you do this, you will have something very cool. So you'll have both graphs in the same plot with different colors. So now you can compare, you can see how cos and sine are going. So this is pretty cool. One more thing you can do is, I'll show here, you can draw a label. You can give this a label. So this is sine and this is cos. So you can have here like this. So what will this do? So one is cos and one is sine, but here you also need to do legend to show the legend. Now you see, so one was sine, one is cos, and this you can see here separated by the color. You can change the color if you want, but generally you don't need to do that because it will be of different colors. And this legend you can put it here. This makes the things very, very easy. Okay, now there's one more thing. Now if you want to add an x-axis, let's just have an x label. So the x label way to go is have this as, I don't know, points. Let's just have points. See, now you have the x label. Similarly, you can also have y label. So here it would be sine and cos, or maybe you can have set y label. You can have comparison of sine and cos. Sine and cos. There you go. I have comparison of sine and cos, you have points. This is very important. Another one which is very important is set title. You can set a title. Just remember this will make your life very, very easy. your college, whether you're in college or trying to submit an assignment to any startup company when you're applying, you can always submit a notebook like this, or you can also have some graphs showing the way you have analyzed the data. This will solidify your application and make you a very strong candidate. So let's just say this is a comparison graph. This will give your title. This makes things look very, very nice, and it shows you that you are actually like pretty, you know everything, and you are pretty in grasp of what you're doing. You're not copying from something. You know what you're doing, and if they ask you how you did this, how you did that, you know everything. Great. So now what comes is a bit different thing. Now we will do, now we'll have a little more fun. So what we'll do is, now let's do some experiments with the figure. So you can imagine you don't have any access here. So it's a 0 access. So it will not do anything. Basically useless. So now comes, let's have a 2D axis. So what does that look like? It's always the same thing, subplots, and now you will give the size. So it's 2 cross 2. So what should this look like? Let's see. Yeah. We have not drawn anything. So it's like 4 such graphs together in the same plot. So let's have these. You can reference by using these. Dot plot. You already have x and y. So it will plot sine here, as you can see. Next comes 0 and 1. You can plot anything you want here. X, z. We have plotted sine and cos. You can also have scatter plots, because why not? Dot scatter. Remember this, you need plot, normal plot, you need scatter plot, and you need bar. Bars, I'm coming. X and y, let's have scatter. So this is a scatter plot, because it's 200 points, so that is why it's very, very close. Otherwise, it's fine. Next comes, yeah, so this is done. This is done. Next comes something different. So let's do, these are all like 2D plots, but you also sometimes need 3D plots. 3D plots can make like the notebook look very pretty when you're trying to analyze things. And you might actually have 3D data. Let's do that. So let's say X is np dot linspace 1 and n. Ys would be, I don't know, let's say it's sine xs into, let's just say 6 pi. Anything, I mean, you can give anything you want. This is just an example I'm giving. np dot cos xs into 6 into pi. Yeah, so now you know what to do. Figure, comma, axis equal to plt dot subplots. Now there's the thing that will differentiate you from the, differentiate it from the 2D plot. So this is basically this thing, projection 3D. This will matter a lot when you're trying to do this. So this basically tells it to do a 3D plot. So now again, axis dot plot, give all three, ys and zs, and then plt dot show. There you go. It's a 3D plot. So this comes in handy, like in many cases when you're trying to analyze 3D data. You cannot obviously have, if you have more dimensions, you do not want to bring it down to 2 dimension, then you won't be able to understand it fully. Cool. Now let's do some classification data. These were all continuous. Now let's do some discontinuous data, that is bar graphs. So let's say we have some data. So apple, maybe, I don't know, let's have apples as 10, oranges as, I don't know, 15. Lemon, let's have 5 lemons, and let's have lime, 20 limes. Cool. So this is the data. So now you have the names and you have the values. So get the names out, because that will help in your bar graph. Data.keys. So it's a standard Python, like, you know, this is a dictionary. So list data dot values. So once you have this, now you will do the same thing again. Pick, comma, axis equal to plt dot subplots. let's have now 1 cross 3. I'll show you 3 different plots. And this is one special argument that you can use to fix your size of the figure or size of the plot, basically. The resolution, technically. Yeah. So let's have bar as names and values. Simple thing. It will plot a bar graph. Yeah. So we have 3 values here. And this is giving names and values. So as you can see, apple, orange, lemon, lime. This shows the value like in a proper bar graph. Next comes the scatter. As I already said, scatter would be something like this. Scatter names, comma, values. You have a scatter plot here, same way. And there's one more thing you can do. Let's say 2.plot. This is normal plot again. Names, comma, values. So you have a normal plot. Now, one more thing that often comes in handy. I had also used it in one of my college assignments. So you can basically, when you're trying to submit a graph and you find that the letters are very long, the names are very long, then you can do rotation. So basically, when you're trying to do this when I was trying to submit a college assignment, I found that this comes in very handy, the rotation. If the names are very long, then you can rotate it a little bit to fit it in the data. So in the graph. So here you can see apple, orange, lemon, lime. This is like pretty small. So let's just make this, I don't know, let's make it lemonade. Let's write that twice, lemonade, lemonade. So now you'll see this. See here, they are getting all over each other, but here they are like very clear. So this comes in very useful. Remember this one? You can like do anything in very, very easily. Yeah. So I hope this was clear. I covered the Matplotlib, Numpy, and Pandas all in great detail. This should be good enough for you to get started on any kind of Kaggle dataset. As I said, just download the dataset and try to analyze it yourself. Try to plot the different statistics using Pandas. Try to manipulate some of the data using Numpy, and try to plot it out and understand everything, the analysis and everything using Matplotlib. This will really help you to get comfortable with data, and you can do easily like any kind of data that is thrown at you. You can just do an analysis of it and put it into different categories, and you will know which algorithm to use next. So I hope this helps. Please drop your questions in the comments if you want me to cover any other function. If you did not understand anything, I would strongly suggest to rewind it and to try to understand it. But if you still don't get it, you can drop a comment below and I'll try to answer it. I hope this helps. Thank you.